Good morning, everyone. Thank you to Verinso team for inviting me here. I'm honored to be part of this event and to present you something that is more, for certain aspects, more futuristic. So far, I saw in the presentation before that the term sustainability, green, reducing emission has been used, and we will continue on this green line, let's say. And it's interesting also to present what we are doing as Vertiv in what we define as dynamic power and new technology. So first of all, let me introduce myself. I'm Arturo Di Filippi, and I'm working as Smart Power Global Offering Manager for Vertiv, and also I follow the business in EMEA. So a kind of a double role, but this one that I'm presenting today is certainly the most interesting, at least for me. So what we are doing is in terms of dynamic power. It's also defined as smart power, but this is the definition that we are giving in Vertiv. I'm not speaking about the company because I'm sure that you know our products, so we are active in the AC Power business. I will directly go to the point and present you what are the initiatives that we are taking. So first is the grid support applications, and this is the first session that we will describe today. We will present what we are doing in terms of initiatives for using the UPS not only as critical protection but also for the grid interaction to support the grid frequency stabilization. And then we are presenting what we are doing in terms of integration of the UPS with fuel cell. This is not something that is available right now, but we are working to some proof of concept, and we will present you both technologies. So, and as you can see from the map that I'm showing, you can also see what is the path that we are envisaging to the CO2-free operation. You know, there are some targets, especially from the hyperscalers, from big customers, to reduce carbon emissions. And we are planning to do that going from the data center today to the data center where we may probably replace diesel generator with the fuel cell, or even use the fuel cell as prime source of power, and the grid will be used then as backup. And then also we are having some initiatives were explained before by the colleagues from Huawei, but there are a lot of certifications that are now used for data center, and also we need to adapt our equipment to comply with this new certification, and also for the life cycle assessment that has been asked for most of the products. Okay, dynamic grid support. So what is dynamic grid support, and why do you see in this picture the wind turbines? It's we define the dynamic grid support as a feature rather than a product, and this feature is used to contribute to the sustainability by increasing the adoption of renewables for some countries. So if you have the UPS, so I will just summarize what will be the outcome of this session. So by having the UPS with dynamic grid support, you will be able to enable from the user side some revenue generation, but also to support the adoption of renewables, because we will interact with the grid and we will support the grid frequency stabilization. And of course, this is also something that can contribute to reduce energy bills and reduce consumption, because we will basically have two services, and these two services that are also seen as grid support, grid services opportunities are frequency management and demand management, or even called peak shifting or peak shading. So what is the frequency management? In this graph you can see what that means in terms of response. But let's consider the grid frequency in Greece. So it's 50 Hz. Then if there are many renewables in some sites, and these renewables, it's very sunny day, windy day, so they are pushing power in the grid, then the grid frequency can increase from time to time. So it could go up to 50.2, 50.4. Well, there are some countries, and especially this is applicable now, and this is used now in Ireland and in Nordics. In Ireland, because the contribution of renewables in Ireland is very strong, so there is a lot of wind over there. And to alleviate this pressure from the grid, we could use the frequency response. So there is a controller that determines that this grid is over or under the threshold, and if your load is able to disconnect from the grid in this period, or if you could charge the batteries with this load in this period, well, this means if you can react to this frequency imbalance with your UPS, then you are rewarded. So you get revenues from the grid operators. And the faster you are able to adapt to this grid frequency variation, the higher is the revenue that you can get. And this is the main usage that we are seeing now for this feature. And then we have the peak shaving. Peak shaving is quite straightforward. It's you have a certain consumption during the day, and you can have some time of the day, the night, where the cost of energy is lower. But that's something that you do also at home. I'll do that when we have to do the laundry, for instance, during the night. But if you have a data center or even other critical infrastructures where there is where a megawatt of loads, well, you could just decide to disconnect during the night and to power your load with the batteries, and then you recharge during the day, and during the night you recharge these batteries because the cost of the electricity is lower. And these two services are part of what we define as grid services, and we are adding this feature to the traditional services of the UPS. So that's the XLS1, our monolithic large power solution that is available in the rating 300 to 1250 kVA. And traditionally the UPS has, since many years, the UPS has the function to improve the power quality because of double conversion, and to provide backup power. So there's a grid outage, the UPS is required to go, and the batteries that are associated with the UPS are basically used only when there is a grid outage. And the rest of the day, the rest of the year, they are sitting there, they are not getting discharged. Of course, you are not consuming the batteries, but at the same time, and this is what we are trying to pass as message, you are kind of wasting some opportunities that you could have in this scenario. So we are connecting to an external controller, to the UPS, and there are some other changes in the firmware, slightly in the hardware, and you can use the UPS also for other functions, and you can see the UPS as an intelligent power converter. How does that work? So this is the question that we receive, and most commonly the second question is, can we inject power back to the grid? So with this, by displaying the operating mode, we try to address both questions. You know how the normal operation of the UPS is working, so nothing to discuss there. It's double conversion. You can also have some other operating modes, but anyway, you get to the load. Okay, this is very simplificative image, but you need to account for some efficiency, but you get 800 kilowatt input, 800 output, nothing else. Then if you have the firmware to support the grid service operations, you could just decide to disconnect from the grid from time to time. And for instance, as we were saying before, you disconnect from the grid where there is under frequency, or just you want to during the day. And in that case, in the battery mode, you get all the load from the battery. You can do the source sharing mode, so part of the power is coming from the mains and part is coming from the battery, or even you can just decide to keep the load, the power to the load unchanged, so it is in this case full load, but at the same time you get more from the grid to power the batteries. So in these operating modes, you see there is no indication that the flow can be in the other way. Our UPS could theoretically do export of power to the grid, but if we do that, the UPS change function turns into a bidirectional power converter that is more close to what we do with the PCS for the solar, and that's why this injection of power back to the grid needs to be carefully evaluated, and this is not something that we can provide as standard. So when required, we need to verify that from CE, EMC, and also from local regulation standpoint, we are compliant. So that's not the standard. And the schematic, so we say that we are connecting to the UPS and grid controller. And why we decided to have it out of the UPS? The main reason was this can enhance the flexibility of using different controllers. So this grid controller is required because there's a need to provide to the UPS some commands, and the UPS has to respond to those commands, but at the same time this controller needs to have the capability to read the frequency. And also, this is, in this case, we are showing the controller of NLX. NLX is an energy service provider, and they also follow all the financial aspects of the grid fast frequency response, for instance. So we are partnering with them to provide this controller that is connected to the UPS, and we can perform basically two types of services. One is the static frequency regulation that is done through dry contact connection between the UPS and the controller, and the other is dynamic frequency regulation, and that's done by basically by connecting through Modbus duplication. And the difference that with the static regulation you have a fixed response from the UPS to grid frequency variations, while with the dynamic regulation you have a continuous verification of the status of the grid. This application usually works better if you have some lithium-ion batteries, and that's another point. So that could work, of course, also with VRLA batteries, but the advantages of having lithium-ion batteries, and here we are showing the Vertiv branded solution for lithium-ion batteries. You can get, of course, the BMS, you can control the batteries, and you can perform more cycles of charge and discharge, because as we will see later, one of the challenges or even barriers that we have encountered so far is the fact that some operators may say, okay, but since I'm using the batteries not just for backup but more extensively, that could be a few times per month, this means that I'm going to the life of the battery is going to be affected by this cycling, high cycling, and so there is an enhanced degradation. So we are supporting this statement, or we are providing a tool that can be used to verify what is the degradation of the batteries if you work with these services, if you do peak shaving, such that the TCO at the end and the business case will be positive for the customer. And let's see, in fact, one application case. So this is something that is currently done by one of the top hyperscalers in Ireland. In Dublin there is in Dublin the grid operator has opened these programs that are called the DS3 programs. As you can see, there are different programs, and the most lucrative, most remunerative one is the FFR, fast frequency response. Traditional installation, no grid support. You just have 1.2 megawatt load, and you want to guarantee battery runtime for 1 minute. You have 6 cabinets for the batteries. If you want to add also the possibility to work as grid services, to add the grid support, then you can add 2 extra battery cabinets. You can extend the runtime, bringing it to 6 minutes. And you can have 1 minute for backup and 5 additional minutes for the grid support. Doing that, you are able to, and if you enroll in this program from Ireland, you can get up to 100,000 euro per year. So first you can contribute to the usage of renewables because you are alleviating the pressure from the grid. And this is one measure of sustainability because, of course, you will be one player that is contributing to increase renewables. And on the same time, you get paid, you get revenues. So you will just need to make sure, and this is something that we can support in this calculation, that in 10 years, the revenues that I get are higher than the cost that I may sustain with these 2 additional cabinets. That is capex, of course, and I have to verify that the degradation of the batteries in these 10 years is limited. So I do not have to replace the batteries in 10 years, because otherwise I may say, okay, but I just want to, I don't want to replace the batteries, I want to keep them at least for 10 years. And it's also a kind of mindset challenge, because it's difficult. What we are, the issues that we are seeing so far, it's difficult for the operators of the data center to change the way they are using the UPS. So they are worried, and there's a point on that. Not saying anything. They are worried that if you use the UPS for some other functions, then you may not have the battery capacity when it is needed. So you can have a grid failure, and since your batteries are doing something else, you may not be able to support that backup power, which is the main function of UPS. And to prevent that, we made sure that in our firmware, in our software, there is the one part of the battery is kind of locked, so it's reserved for the backup time, such that in all conditions the grid services will be stopped if you want to go and get capacity from that part. So that is something that we have implemented with our firmware. We spoke about the AXL-S1, that is our modularity solution, but we can do something like this also with the 3Energy Cube. That's our modular solution. We are now going to install one solution of 3Energy Cube with peak shaving for a facility that has many people during the day and nobody working there during the night. So they want to have this peak shifting, because they say, okay, I just want to use the UPS and to during the night I have nobody there, so I don't need to power all the cooling system and all the other loads. And therefore they want to do this with our UPS such that they can just increase the consumption during the daytime, working time, and they get that from the batteries. In this case, we are using some Vision batteries with our modular solution, and this is something that is already available from now. Coming back to the point, so the criticality, the main issues that we are seeing when speaking with customers is okay, but what about the batteries? after how many years shall I replace the batteries? So we can support in the sizing. We have this tool, we have developed this tool, and we can give indications of the benefits of having peak shaving, having frequency regulation, and to make sure that even if you have to replace the batteries, because there are some programs that are more intense than others. There are some programs that require the battery discharge every day. This means hundreds of battery cycles per year, and this is something that will at the end require a replacement of the batteries in 5 years, but that depends on the program. Well, in that case, we need to provide you some evidence that even if you replace the batteries after 5 years, then in 10 years, you will still have some benefit from that point of view. I think that I can move on. So if there are questions on this part, please let me know, raise your hand. I've tried to ask some questions myself based on what we have got so far during the webinars and in all the meetings that we have had with main customers. And probably last question is, okay, is this available in Greece right now? I don't think that it is for the moment. It is that's a decision from the national grid operator. In Ireland, in the Nordics, it is available, but we are seeing that is pretty quick, the deployment in other nations. So last year in Poland, for instance, that was not present, but now they are working to have this program available also there. So we have to stay tuned to verify if the frequency regulation is available in Greece. But the peak shaving is something that you can do, because that is not related with any regulation and any frequency program. We will now verify a little bit fuel cell. So that's more futuristic. Now I will not say futuristic in terms probably not 20 years, but it's not this year, not next year, probably will be 2025, we will start to see something. Right now we are working at the proof of concept. But the main question is, okay, what is a fuel cell? So the fuel cell is an electrochemical device that converts the chemical energy of a fuel that could be hydrogen, but could also be natural gas, and depends on the nature of the fuel cell, and that converts it in electricity and water. If the hydrogen is the fuel, there is no CO, there is no CO2. So they are green, they are emission free. And there is no combustion at the end. They are not working like batteries, so they have to be fed every time. So they do not have a capacity where they can store energy. And depending on the fuel, we will have different type of fuel cell. And they are important. You may have already seen somebody that is asking for fuel cell for proof of concept. Fuel cell are now used in the cars. In some cars, in some buses, you may get on the bus and there is a hydrogen tank on the top of your head, and we are not scared. So this is not dangerous, but that has to be, of course, proven and certified. They are important because if we use hydrogen, then they are free, and Microsoft has declared, has stated that they want to be in their sites emission free by 2030. So by 2030 they need to get rid of diesel generator, and they have to replace it probably with batteries at first place, but then the idea is to use the fuel cell. And we are targeting and we are describing here two types of fuel cell. First is PEM, polymer exchange membrane. These fuel cells are working at low temperature, and they are having one membrane. This membrane is where actually the reaction takes place, that is the electrolyte. And they are working with hydrogen. So if they get CO or other fuels that are not hydrogen, so they get polluted and you need to replace everything. So no good. And then we have the solid oxide fuel cell, SOFC. These fuel cells are working at high temperature, and main characteristics that they are working with natural gas. So this is good for implementing the fuel cell now, for the fast adoption of this fuel cell, because you have already the natural gas infrastructure which is ready, up and running, and they have high efficiency. But issue is that it takes hours to heat them up, and so because they are working at high temperature, and so they are suitable for prime power. I will not mention there are other type of fuel cell, the alkaline fuel cell. So they are famous because they were part of the first program from NASA in the 60s probably, but they are not so used and for our goal we are not considered them, and as well as also the molten carbonate fuel cell and the phosphoric acid fuel cell. We will focus on the PEM and solid oxide fuel cell. So the pros and cons. The pros of the PEM fuel cell is the fact that they are emission free, and this is why they will be adopted now from these hyperscalers. Emission free, and they are working at low temperature, so they are quick. You can use them for a backup power application in replacing diesel generator, because they take seconds to switch on and to switch off, and they can cycle. So they can cycle frequently in small time. Of course, they need hydrogen, and right now, if you get out in the street, you do not see so commonly some hydrogen tanks or the hydrogen connection. So that's, unless you have your own trailer, and we are doing that in our site as we will show later, it's difficult that if there are no programs from the national programs of European programs that are promoting the hydrogen. There are some programs, but not yet at the level that we were expecting. It's difficult that you can do that. And then they are very, they are delicate, so they are sensitive to pollutants, and so the fuel, but also the air itself, which is contributing to the reaction together with hydrogen, needs to be clean. And for what concerns and of course the fact that they are cycling a lot, because they are for application, can also affect their life, and we will see later how. And the advantage of the other fuel cells is that of course the efficiency is very high, and that's the reason why they need to be used for prime power. So they could take hours to be heated up, but if you use them as prime power, they can last very long in time. And used with high efficiency, they can be more efficient, of course, than the diesel gen, and can be used in the data centers as primary source of power. But if you have, for some reason, some issues, and you need to switch them off, then it takes a long time to power them up again. So that's why the thermal cycle, and also these thermal cycles can stress the materials, and that's not good for the life of the stack. In how we envisage the operating mode of the fuel cell. So if we use the PEM fuel cell, for instance, we are trying to understand how this fuel cell can be integrated with our UPS, and we are seeing that we have different operating modes, that the fuel cell is going to be in idle mode, start up, shut down. So we are trying to understand from suppliers, and you see here the name of Ballard, because Ballard is one of the suppliers we are referring to for this type of questions, and they are probably one of the few able to scale the system up to megawatt scale. We are trying to understand how much time basically it takes from the fuel cell to go from the off to on, and how we want to integrate the fuel cell with our UPS. Option one is what we could do now, and I will explain why. So Option 1 means that we are connecting the fuel cell to the batteries, lithium-ion batteries. Basically, having the configuration in DC can improve the efficiency, because you have one conversion less, so you don't go to the AC here. Like in the diesel gen, you have the inverter. Here you keep everything in DC, and moreover you can benefit of the batteries to absorb the power transients that are typical of the fuel cell. So the fuel cell are not able to react to the power transients so quickly as the diesel gen. They need to dissipate some power, and that's why using the batteries, this is something that we can do. And we have moreover, customer are asking, okay, but with the load, I just want to see the battery from a load standpoint. And in fact, with this configuration, they only see the battery, because at the end, the fuel cell are only charging the batteries. And we are studying, we are working to understand from how the UPS control will need to be modified if we have to control set point to the fuel cell. And as you can see here, we are running some for both configuration as PEM as backup power and also as SOFC as prime power. We are studying and trying to work, try to make it work, and how the different phases of the grid and fuel cell have to be connected each other to have it work. So this is just a schematics to show you that we are considering all the information, and we have summarized some of this information in a white paper that we can share later on. The end goal will be to have an energy management architecture. So we will start with the UPS controlling the fuel cell, and at the end we will have the UPS that has grid support. In future, we are going to have an energy manager that can control all the sources that are connected to the UPS, and can decide when one energy source must be preferred to the other. This means that if you have fuel cell, you can, so right now we are just showing you that this can be used as the backup power application. But if you have the hydrogen at site, then probably this is also something that you can do, and you can do in other times of the day, not just when you need that for backup power as load sharing. That was the funny part, but then we had to face the reality. And the reality is why I told you before that probably this is not something that we will have next year or in 2 years from now. There are some limitations and constraints. So first one being, we have mentioned that hydrogen availability, and we are struggling to get 2 hydrogen tanks at site where we are developing this proof of concept. We need to get the approval from the city council. You know, we are the headquarters in Delaware, in Ohio. It's small, it's not that big, that city. We had to go to the city council to ask the approval for installing these hydrogen trailers at site. So it was funny. They told me that it was like the if there was in a meeting with some people with kids and so on, they were asking, yeah, but this is dangerous with the science and so on. That's not how it works. This is safe. And of course, the other main issue is the cost. You see those numbers. It's not wrong. We are speaking about millions if you want to go in megawatt scale, because the cost right now of fuel cell is around $2,000 per kilowatt. It's huge. It's not something that you can currently do with your. You cannot replace the diesel generator with something like that. Our roadmap is, in fact, first to start with step one, and this is the same roadmap of our customers. So the adoption of fuel cell for data centers will not be in the order of time of months. Everyone will start with this step one, that is proof of concept. As in terms of proof of concept, we are doing, I will not I have not explained the other steps because the proof of concept is mandatory to have also the implementation of this feature on UPS on megawatt scale. We are doing some tests right now of connection between the battery and UPS. That's the configuration of the test that we are going to do in Denmark next week. So we are connecting the UPS with some fuel cell from Ballard, and the target is to verify the compatibility between these systems. We want to verify that if you connect the power coming out of the fuel cell to our batteries, it is not blowing up, it is working. And once we have done that, we can proceed with implementing the control on our UPS. And we are going to create a showroom in Europe at Ballard. So if you are interested later on in witnessing this application, this is something that you can do. We can just bring you there and to see what we are doing in Denmark. But we are targeting to have the same in Delaware. I was explaining what we have done to have those trailers. That photo is not showing what the trailers that we are going to have inside. The trailers that we are going to have are smaller, but we are placing them in some area. Later on, we have a picture of this part. In Delaware, the proof of concept, we are going at megawatt scale. So we are connecting 8 battery cabinets with a 1.2 megawatt UPS with 400 kilowatt of fuel cell. 400 kilowatt fuel cell, it's huge, it's impressive, it's very, very expensive. And we are connecting also the DC-DC converter to this solution. And we want to verify that the same solution that we are now developing in Denmark is working also at higher scale, because at the end, the target will be to have 10 megawatt of fuel cell. And probably for smaller application, you may have already received some requests of fuel cell for smaller power, 100 kilowatt, 200 kilowatt. Well, that's something that we will do later on once we have seen that the fuel cells are working, because also for us it's a question mark which is the life of fuel cell. So we know that now we have electrical vehicles, we have batteries, they work, they have to be replaced after some time, but they are working. But we don't know the same for the fuel cell. And let's take a closer look to what we are. That in that area will be the demonstration area. It's where we are going. That is the area in Delaware. So we are going to install the fuel cell and the DC-DC converter in a container, and then we are placing then the cooling system that you see here on top of the container. The fuel cells don't have to be installed in the container. They are ATEX certified. They can be also placed outside. But for the customer experience and also for us to have some area of demonstration, we are going to place them in the container. And this is the area where we are going to place these hydrogen trailers. The idea is here to target 48 hours continuous operation. So we have sized the hydrogen trailers to target this requirement. This means that the hydrogen in the trailers must be covering probably 36 hours, and because we do not want to get 3 trailers, we just stick with 2, it's costly. So when we perform the 48 hours continuous operation, we need to call the hydrogen provider. They have to come with their tanker, they have to refill this storage. And this is also a test to verify that this is working for megawatt scale. And this part that you see, gray one, okay, this is the DC-DC converter scheme. DC-DC will be provided by Ballard. And why we need the DC-DC? Because the voltage coming out of the fuel cell is not at the same level of what we have on the batteries. So to make them compatible, we need to have some DC-DC. This is something that we will not have in the future, because in the future we're going to connect directly the fuel cell to our DC bus. It's not just PM fuel cell that are working with hydrogen. As we were mentioning before, there is another type of fuel cell, solid oxide fuel cell. And for this, we are already working to an European project. And the European project is A2P2. This is public. You can look at the website. And for this A2P2 Eco Edge Prime Power Products project, we are working with, this is funded by the European Commission. And because also the European Commission has targets to go to carbon neutral by 2050. We are working on this project with some partners, and the partners are, so the fuel cell supplier is Solid Power, now Solid Hera, and we are working with some other partners. Also there is the hydrogen supplier. We are going to install all these fuel cells in a container, in a power module. The power module is from Vertiv as well, from IMS, our division of integrated modular solution. And this will be a 100, well actually it's 80 kilowatt net power. And the fuel cell need to be installed in Milano, in Italy. And the end user will be Equinix. So Equinix, Microsoft, I have mentioned to you some of the key players that are working in this market, and because historically, if they are going in this direction, of course we can also be sure that other players will go the same one, and that's why we are installing the proof of concept. We know that there are barriers to this implementation. There is not just the hydrogen, it's the safety. We are struggling to install lithium-ion batteries in most sites because some customers are questioning the safety of these lithium-ion batteries, which makes sense. So we have to provide all the documentation to defend our position. The same will be for fuel cell, but at the end, sooner or later, we will need to use something in place of the diesel generator. And we can use the batteries, but for 1 megawatt you need many batteries, and if you want to get to 10 minutes you will need a very large footprint. That was last one from me, and unless you have any questions, thank you for your attention, and it was nice being here. Thank you.